This topic, functions, is one that students really struggle with. So I'm going to try to go through this a little bit more slowly so that you can fully understand what functions actually are. And way back in year 7, or perhaps even before, when you were first learning about your algebra, you might have had like a function machine like this, where you had your kind of input and you put a number into the machine, and because of bid mass we would do times 2 then plus 1, and that would give our output. Okay, so this was like the earliest kind of introduction to algebra. You might not even remember doing it, or perhaps your school didn't show you this, but we take a number, think of a number, times it by 2, add 1, and that will give you your output. Okay, so this is our earliest kind of function that we may have learned about. Think of a number, times it by 2, add 1. And what we usually have here, when we have this relationship of 2x plus 1, it's usually in a relationship with y. Okay, because when we relate the x and the y, we can create some sort of graph. Okay, a relationship between x and y. And so you've done this hundreds of times. You've done your sort of x and y table of values. You put in sort of a 1 and you get 2 times 1 plus 1 is 3. 2 times 2 plus 1 is 5. And essentially when you're doing this, x is your input and the y coordinate is your output. So you can link these together. When x is 1, y will be 3, for example, and you put a little cross. So you've been doing that over and over and over again till boredom for the last however many years. With function notation, all we have to do is take the y out and replace it with f brackets x. Okay, so f brackets x, which we shorthand to f of x. F of x is how we say this. F of x is just another way of saying y. So I could literally replace f of x here. I could replace it here. If you understand that first, f of x, then that is the huge part of functions down, because at the moment this f of x looks very abstract. What the heck does it mean? All it means is that you take a number in the brackets, like 2. I'll choose a different one. Let's do 3. And you're doing the function. This thing here is the function. Times 2, add 1. Okay, so whatever you put in the input, x there, we replace the x with a 3. You're doing 3 times 2, add 1, which would be 7. Okay, just like you would do here, you would go 3 times 2 plus 1, that's 7. You would do that so quickly. But when you see it in this f of 3 notation, it sends students into a spin. Okay, so first thing to remember, f brackets x, f of x, is just another way of saying y. And when you see x, you replace it with whatever went in here. So let's try f of 10. Okay, f of 10 is the same as having 10 here, but you would do 2x, and my advice to you is just to put brackets wherever the x is and put this thing in the brackets. You're essentially replacing x with brackets, and that allows you to just insert the number into the correct place and do 2 brackets 10. 2 times 10 plus 1 would be 21. Very straightforward. Okay, it's just a different way of writing our y coordinate. Okay, Now, this topic does obviously extend and branch out a little bit. So I'm just going to show you a common question that you would see. We're going to stick with our original function. Let's just write it again over here. F of x equals 2x plus 1. And they might say solve f of x equals 31. Okay, solve this. So to solve this, we take our function 2x plus 1 and we put it equal to 31. So f of x was this and we make it equal 31. And if we go back to our original input-output machine, when you solve, you're going backwards. So we're actually starting with our output of 31, and I want to know which value of x would have given me that, which is what we always do when we solve an equation anyway. So I'm going to go in reverse. I'm going to subtract 1, and I'm going to divide by 2, and that will give me my input. So when we solve an equation, we reverse BIDMAS. I'm going to subtract 1 to get my 2x equals 30. And then I'm going to divide by 2. So divide by 2. That'll give me x equals 15. Okay. So essentially, when we're solving this and we're trying to find x, we're just doing our normal solving of an equation, but also we're reversing the function. Okay. We're reversing the function, subtract 1, and then divide by 2. And that will give us 15. So it would have needed to have been a 15 in here to give us 31. And that's how we solve it.